Okay, properties. This is a nice example of the wonderful people who invented C# doing a thing that makes your life as a programmer slightly easier. In other words, I'm not going to give you any magic which makes something possible, but I am going to give you something which is kind of nice to use, and it also forms a big part of how a lot of the C# libraries work. So we have to know about properties, and they are kind of useful. So let's spend a few minutes getting our head around what they are. We know that a program is made up of classes, and a class contains data and behaviors. Which of those two is the private one? The data or the behaviors? Data, because we don't want anybody having uncontrolled access to our data. We want our data to be private, and the behaviors that work on that will make them public so they can manage what happens to the data. The data lives in member variables and is protected by the methods, and we know from a design point of view the name of the game is figuring out what the data needs to do and then exposing methods that provide that behavior. If there's no reason why you ever want to set the account number of a bank account, and there isn't, then don't provide a set behavior, just provide a get. Set the thing once when it's constructed. You get this quite a few times. If you have stock control kind of stuff, you're making objects to represent things you're holding in stock. You might have a date of manufacture member in your class, which is when the thing was made. You'll set that when it's constructed. You might provide read access to it via a getter, but you'll never make a setter because that would just be silly. You don't want to change the content of this thing at any point. So you decide how that's going to work. You manage that. You make your business objects do what the problem demands, and then away you go. And like I said, like you said, we make the data private and we make the methods public, and you call the methods to get controlled access to the data inside the class. And this means that anything that happens to the data inside your class is controlled. And yeah, the bottom bullet point's worth bearing in mind because it's very, very true. Programmers love having control. I don't like it if somebody else is sort of messing with my systems. It's not good. So I like it if I get control when they try and change things, and that's how our program tends to be best made to work. So none of this should be news. Everybody should be okay now. I mean, the thing that I'm trying to avoid is you knowing what private and public mean, but not knowing when and where to use them. This is the thing about programming. You can learn that a for loop lets you make things lots of times, and integers can store ints and all that kind of good stuff, but what you really need to know is when to use those various tricks and tools and machines and bits and pieces. So knowing what private means will probably get you a couple of points in the exam, but being able to apply it will get you a job as a programmer. There is a subtle difference here. So keep all that in mind. I mean, that's the best if you're having problems with the course because you've learned this stuff but you can't seem to figure out what it means when you write a program, then always head back to the problem you're trying to solve. And the problem you're trying to solve is, I want a bank account that people can't mess around with. I want a bank account that won't get me fired one weekend when someone takes all the money out of everybody else's account and runs off with it. I don't want that to happen. And if it does happen, I don't want it to be my fault. If it's me doing it, that might be good, but we'll leave aside cybercrime at this moment and move a bit forward. So go back to, why am I making this private? And the answer is not because I want to protect it particularly, because I can't really do that. It's because I want to control access to it. I want to get control when someone changes that, and then my code can make sure that bad things can't happen, or I can track things that do happen. So that's kind of why we do this. And so the thing about programming is you can learn about for loops and ifs and conditions and whatnot, but it's the applying which is the skill, really. That's the thing that people don't hire you because you know how a for loop works. People hire you because you can write programs, and the trick to solve the problem is to keep on writing code, and don't just do the coursework. Do other things as well, just for giggles. So there you go, that's my sales pitch out of the way. Moving on. We know about the account class. We're probably becoming a bit bored with the account class, but a couple more weeks and we'll be clear of it. It's got stuff in it, and we provide methods to get hold of things in there. And we've been doing this for a while now. The balance is private. We have a pay in funds, a withdraw funds, and a get balance method, and away we go. You all okay with that? So that means that whatever object I give you, whether it's toothbrushes, chickens, trees, elephants, or whatever we like, you could think of things we could store and how we could manage controlled access to those things, correct? Might happen one day, you never know. So, we're all good with that, that's absolutely fine. Let's just take an example. This is probably getting a bit old, because do you folks have checkbooks? Do you have money you can write? You have money? Okay, it's a good starting point. When I was younger, you get checkbooks and you could write, pay, whatever, and you pay for things with checks. Nowadays everyone uses their bank cards for this, but in the old days, you could still use checks for things like paying rent and all kinds of other bits. Sometimes folks insist on a check and nothing else. I keep a few lying around. And when I was a student, the banks gave all the students free bank accounts and inducements, and one of the inducements, you could have a checkbook that had pictures on the checks, and this was actually quite a posh thing apparently. But you've got this idea of a checkbook is a thing the bank gives you so you can write checks, and you probably have one lying around you use every 3 or 4 months for this, that and the other. If we think about our bankers having 3 different kinds of checkbooks, a standard one, a picture one, and a braille one, there's also left-handed checkbooks. They're quite, a friend of mine had those, because if you're left-handed it's very hard to write in the checkbook if it's that way around, apparently. So, but we have this thing in the bank account that we want to keep track of. A similar thing, we'd use that for stuff like, what kind of account is this? Is it a credit card account, a checking account, a savings account, a mortgage account, blah blah blah. And so we've got this thing we want to store in the account and keep track of. Right enough. Now, I like enums at this point, and we have covered them. I did mention them last year. They're a variable type that you can invent. So I can say, I want this variable to have these particular variables, and you use them all over the place. If there's just 2 possible states, you can use true or false, you can use bool. But if there's 3 or 4 or 5, use an enum. These things are great. So I've got 3 different ones here: standard checkbook, picture checkbook, and braille checkbook. And these are all stored in a variable type called checkbook styles. So you can regard this as, it's a bit like an int, but it only has 3 values and they've all got names. So it can only be standard, picture, or braille. And so it's a way of effectively mapping things I want to store in my program onto specific values in a variable. I use this in games. Sprites in my games are either active, asleep, chasing, or dead, say. And so I've got 4 different things. The game itself, we're either in the attract mode, we're playing the game, we're showing the high score table, or we're back to the attract mode. So I've got to get a 3-state enum that controls how my game play progresses. You see this all over the place. Bank accounts are either open, closed, under investigation, archived, blah blah blah. So you've got this thing where you can roll your own types and put whatever values you want in them. And so having made the variable, there you go, there's my alien sprite. I can then pick the values that the variable can have from a list: asleep, hiding, hunting, damaged, or dead. That's probably about all of us, isn't it, really? Is there much else we do? Maybe not. There isn't happy in there. That's a bit unfortunate. Never mind. Who want to be an alien? Yeah, okay, moving on. That's my style. These are the things that I want to hold in there, and I'll make a variable of this type in my count class. Let's just do this. let's go into the code. Here we go. So I've forgotten what they were, but I'll remember in a second. So this is my account. So in here I'll go enum. Checkbook type. And then I'll go, what was it? Normal, Braille. I don't know how you write in a Braille checkbook. That's interesting, but we'll gloss over that. And then this picture. Right, that hasn't actually made any variables. It's just made the type. I should probably make it public, otherwise no one can use it. And in here, I can now make a private variable called, I don't know, well, of type checkbook type, and we'll call it checkbook. And that's how I do it. So this guy can only have one of these three possible values. This isn't a particularly meaningful place to do it, but if I go checkbook, oh gosh. Okay, can't use it in there because that's static. Put it in here. Love my life. Checkbook equals, and good old IntelliSense lets me pick one of the three possible values, and so that's how I'd say the checkbook was normal. And I might actually pop this in the constructor. So what I'd do is I'd actually take that out of there, go down to the constructor if I've got one, somewhere I will have, keep on going, here it is. So if I do that, it means that when you make a brand new shiny account, the checkbook type is set to normal. Does that make sense? If you've got any kind of concerns about how this works, go back to the intent. Why am I doing this? Because I want to keep track of what kind of checkbooks this guy is using for his account. Okay? Simple as that. And I've decided I've got this thing. If we have a new kind of checkbook like left-handed, how do I deal with that? So if a new kind of checkbook comes down the tracks, how do I handle that? What do I do? Once I've charged the customer a ton of money, of course, I would then drift back up here and I go into, oh, I've got one there as well, wonderful. I go into here and I just go, I don't know, left-handed. No, let's just use camel case. You know why it's called camel case? Because it kind of goes up and down with the capitals in the middle. That's whatever stuff you learn. Right, so I've got left-handed, I've got 4 types now. So I can whack this thing into my object and I can use it to keep track of what kind of checkbook we're using. It's private, so the code outside the account class can't see it, which is what I want, and I can then manage access to the thing. And I could sit down and I could write a couple of methods, a getter and a setter. What's the posh name for these guys? Well, which one is the mutator? There's a choice of 2. The setter is the mutator, that changes it, whereas the accessor, which provides access, is the get. And this is a convention, if you ever get round to writing any Java, which is a good thing to do occasionally, especially for money. Java's very big on gets and sets, and in fact the way that some of the Java standard libraries work, they have gets and sets built into how they work. So they will expect you to work like this, and if you make your classes work like this, then it ties in with how Java is designed. C#, yeah, you can do a get and set if you want, and quite a few bits of software do that, but C# has these property things, and they're much, much nicer. In terms of how I'd use this, yeah, make myself an account, set the checkbook to standard or whatever, and I call this method. When I call the method, this code runs and it takes the parameter and slaps it into the member variable. I've no need for validation, which is nice, because with this being an enum, you can't put an invalid value in. I might have things like only people who have an income bigger than 20,000 a year can have pictured checkbooks. Could I do that? I'd enforce it inside here, And so I could have an if condition there, if income less than 20,000, then throw new exception, blah, or return false, or whatever I do to do with errors. But that's how I do it. Okay, so I can tell the checkbook, so I can tell the account, this is the kind of checkbook that you're using. Everybody okay? So I've got this, we've done it before with the age and all kinds of other things, a getter and a setter and a private property. And it's standard programming practice. And yeah, I quite like using them. They're okay. Bit of a pain to type in. I could put validation in. That's all good and fine, and that works. But C# has a much nicer way of doing it. I think Java has copied now, although I may be wrong on that. And these things are called properties. They don't do anything you can't already do, but they're really rather nice. And some programmers call this syntactic sugar. It's just a sort of a nice thing to have. It's a bit like central locking on the car. No one needs central locking, really. It's just nice that everyone can get in at once. It's kind of cute. So it's a bit like central locking, but for programming languages, which is fine. I'm good with that. So this is how you do it. You make yourself a property, which you give a particular name, in this case checkbook, and it has a get behavior and a set behavior. There's a whole bunch of new keywords just appeared on this slide. I've got this guy here, which is the word get, and I've got this thing here, which is set, and then I've got the actual value. What happens is that if you call the get behavior, you get the actual value in the class. If you call the set behavior, the value being fed in, you can then use it to update elements in the class. Now, I'm only giving you really half the story here. If I go to the next slide, we can start to look at how it fits together. It must return the value of the type, but I haven't really told you how it's used yet. This is the best bit. There you go. Once I've made a property, I can just use it like I would a member of the class directly. So I could just say a.checkbook equals bang, and that will cause my set behavior to run. If I try and read it, it'll cause the get behavior to run. I'll show you what I mean. Okay, so I get my mouse back. So in here, let's, underneath my checkbook, let's give ourselves a couple of public. I've called it checkbook with capital letters, and oh gosh, public checkbook type. That's my property going to be called capital Y's in a way. Right, okay, so done that. So now it needs a get and a set. So in here we go, get, and the get behavior returns. I'm going to rename this guy. I have this convention where I go, I'm going to call it checkbook value because that's what I tend to do. Return the actual value. And if I go set, I do the assignment. Isn't this exciting? No, not really. So you can think of this thing as being fed in to the set behavior. I'll just line that up because it's important these things are tidy. This is my set behavior down here. This is my get behavior up here. I'll just do something disgusting to actually allow me to play with this. So in here I'll just get rid of this code here, and no, I'll leave that up. Why not? I can go account A equals new account, make myself an account, give it to Rob, and give it a serial number of 1234. Okay, and then I can go a.checkbook equals checkbook type. Let's give it a picture checkbook, please. Thank you very much. Picture. Thank you. Right, now run the program. Put a breakpoint here so we can watch what happens. Bang. No! I spelt that wrong. Oh, I changed the name. You have to go away now. I'm bored with you. Oh, checkbook value, isn't it? I'll just kill you off. There you go. If you won't compile, just delete it. That works every time. Whoosh. So, we've got an account. It's called Rob. Account number 1234. Step into the code. Yeah. C# has this thing where it doesn't let you use breakpoints inside properties. So I'll put a breakpoint here. Whoops. It normally steps over properties, not into them. So I'll just stop this. And run it again. Bang. Run on. Bang. So when I do the set, the value here has got picture in it. So and it'll just get put straight into here. So the thing which I like about properties is that this looks remarkably like a simple assignment. We're not having to call methods and get values back and stuff. It's a simple assignment. But when I do this, it actually runs a piece of code. Okay? And that piece of code can manage access to the thing I'm trying to touch. So they are a good replacement for get and set, because they're actually a lot easier to use when the program runs. Is everyone okay with that? They don't do anything that get and set doesn't do. They just make the code a little bit neater in that rather than calling a method, I'm doing an assignment. I mean, I can do this kind of thing. If I stop the code, well, don't need to. I could go something like account dot checkbook type x equals a dot checkbook. What will that do? It'll go off and fetch the checkbook type from the account and slap it into X. If you want proof, then here we go. Let's give you some proof. Set the account thing to picture. So we run the set behavior, which I can step through. Doink, doink, doink. And then on to the next line. Read this back. Doink. And now we're in the get. It'll get that value and return it back. Doink, doink, doink. And so what ends up in X is, I guess, the word picture. Keep stepping. Hold the faith. Bang. Now take a look. X. Yeah, it's picture. Okay, so it's easier than getting set, but that's about it, really. The nice things about it, well, the code's tidier, and I quite like that. If you want to, you can leave out the set part, so you can provide just a get behavior. And so you've got like read-only properties which you can look at but you can't change. That's fine. I could put a balance property in the account, so rather than calling get balance, I will go rob.balance and get the balance straight out of it. You can create what you might describe as write-only ones, but I can't really see as much of a use for those guys. So just providing one or the other gives you basically a way of limiting what can be done with that particular object. One of the things that I do, which is nice, is you can have multiple read-only versions of the property, each of which provides the information in a different way. For example, I can have one that's called height in meters and one that's called height in feet, which does the conversion internally for me. You see this, I'm messing around with games at the moment, and so I can have a sprite on the screen, and I can think of this thing here as either being the X value, or I could call it left. If you look at some of the objects in WPF, they have a left property and a top property, which are the same as the X and Y values. And they're exposed as properties, and one just returns a copy of the other. They also have a bottom property and a right property for these positions here and here sometimes, which again, they're just worked out on the fly and returned straight back to you. and they make it a little bit easier to work with the objects. Does this kind of make sense? I mean, things like string.length or collection.count, these things are actually properties. They aren't fixed values, because the system will come back and give you whatever number it's worked out. Particularly count, because count might actually fire a behaviour off to do some counting for you, if that's what it has to do. And so, yeah, here you go. This kind of stuff, scores.length. It's read-only. You can't change an array size by assigning to length, but when you run it, it gives you that information back. And these things are used all over the place. All the things in the XAML, textbox.text, that's a property. When you assign it, what happens is that some code runs inside the property to perform the assignment. That's how it works. So they're used a lot in the C# libraries because they're a nice way to organize things. Use them with care. The second bullet point on here is really important to me. If I call a set method, it can return true or false or an error code if it fails, which is grand. So I can know it didn't work. I can test what it did to see if it worked or not. In a property situation, it can't. I mean, I could make a set behavior in here which completely ignored value and did nothing. The user of my object wouldn't know that, and there's no enforcement by C# of the use of that thing that gets pushed in. And if I don't like the value I'm given, I can ignore it, but I can't tell the user of my class that it's been ignored, which means the user of the class has to do the set and then read it back and see if it's changed correctly, which is a bit tedious. But it's fine. I don't mind that too much. It depends on what the property is. What you'd also find is quite cute is that there's if I assign a property, it's one line of code, but you might have thousands of lines of code running on the back of that. When you go textbox.text equals blah, a whole ton of code runs inside the Windows system to actually realize that behavior, but you don't see it when you make that single simple assignment. And one other thing which is kind of cute is that some versions of Visual Studio will take a member of a class. I'll show you what I mean on this one, because this is kind of sweet, assuming it works, which hopefully it will. I'm using so I'll put a thing in here. I'll go public enum account type, and let's just have two. Let's just type it right. Okay, we can have current and we can have savings. Okay, these are my bank account types, and in here I go public account type. Let's call it type, why not? And then, okay, I want to propertify you, so I double click on you and I go for quick actions and I go for encapsulate fields type. Still bang, and nothing happens. That's annoying. It's supposed to build the getters and the setters. I think the problem is that this is my try that one, still not doing it. Oh, there we go, there they are. It's actually made the gets and the sets for me. I've done it twice actually, because I asked it to do it twice. That's embarrassing, go away. So, can you see that I called it type with a tiny t. I then ran that piece of magic on that property, and it then made me this code. Now, if you don't believe me, I shall do it again. Delete this. It's gone, right? It's a bit like being a magician. Right click on here, go for quick actions, and then we go, which do you want, that one or that one? I'll do this one. Bang. And it puts the code in for me. Changes it to capital T, and then makes it, effectively it's built this code for me, which is nice. So it's quite easy to take a public member and make it into a property which is managed in terms of getting set. Then you go ahead and just fill in those bits of boilerplate code. That's a cute thing to do. And there are commands in which will do it for you. Yeah, it may be useful. And that's the end. Any questions about properties? If you can't find them, you can look in the Lost Property office. Okay, they're on. Yeah, please do keep your hands warm. Right, so let's move on. Shh. Shush. Let's have a little touch of etiquette, because I'm very big on etiquette, as you all know. I'm trying to make you into proper programmers who actually write nice code for lovely people to use, okay? That's where we're going with this. And there's certain things that it's worth knowing about when you start building objects and creating solutions from them. And this is all to do with etiquette, which is, if you watch Jane Austen adaptations, they're very big on that in her films as well. The wrong kind of dancing or crooking your finger when you drink tea or whatever, it's all very bad. And so, yeah, let's try and teach you folks some etiquette. This is good practice. You should do this. It also gives you an insight into how programs work, so we can start looking at other things that they actually do. Everybody's okay with this code. What I'm doing is I'm setting the variable I to 99. It's an integer. When I write it out, what will it print, folks? 99. That works. We talked in the first few weeks of this course about the fact that's a bit weird, because it probably shouldn't work, because if I try and read a string and use it as an integer, that doesn't work. I have to use parse. So why does this work? Well, because C# has a behavior that takes any old integer and turns it into a string. We have a thing called toString which does this for us, and I have mentioned this before. I'll make a brand new project and I'll show you what I mean. Although I think you've already seen this, so I'll make a new project and we'll call it console app for old school style, and we'll call it Etiquette. Okay? Is it etiquette or etiquette? Etiquette, that'll do. So yeah, close all that lot, don't care. So in here, I can go int I equals 99, and then I can go console.writeLine I. And the system converts my value into an integer and prints it. Straight into string and prints it. So if I run this, up comes 99. Well, hey, it works. Now, the reason why it works is because every class in the C# universe has associated with it a toString method, which converts that class instance into a string. And this string is, generally speaking, stuff what describes what's inside this instance. In the case of an integer, it's the values, it's the string that represents that particular number as a string of text. In the case of a string, it's a string. I think I've done this to you already once. I've done this particular trick where I go hello world dot toString. Oh dear, oh heck, my keyboard's going nuts again. Dot toString. Yeah, so I can get the string version of a string, and I can get the string version of the string version of a string, and it's quite happy to do this until the cows come home, and it works absolutely fine. I can even go and write console.writeLine 99.toString. I can explicitly say take that value 99 and give me the string which it represents, and that'll work fine. It'll print out hello world and 99. That's all fine and good. And the reason this works is that every object in the C# universe has got a toString behavior. Okay with that? So there are things that objects can do, and one of them is, hey, give me your string version, please. And so when we call something in a context where we'd like to have a string but we maybe haven't got one, like here, where this thing here is an integer and we'd like it to be a string, the compiler goes, okie dokie, I'll call your toString method, and away it goes. And int's got toString built in, so has double, float, decimal, all that kind of good quality blah. So let's just do some theft of code. If I go into here and I open up Account Manager, which is my XAML version, which is fine but not very good for testing, and I go into the account class, anytime, take your time when you're ready, thank you very much, go into here. I'm going to steal the entire account. I'm going to paste it in. Let's not do the entire thing. Let's just go for the class itself. Have you ever done this? Compress it, and then copy it, and then paste it back. Bang, and that works. Cute. Not worth a round of applause, but still cute. So I've got account class. Okay, so now I can go in here and I can go. So it gets boring very quickly. Account A equals new account. Let's give it to Rob. Oh dear. And let's give him account number 1, 2, 3, 4. Fine. And then I go console.writeLine A. Will that compile? I know that. That will compile. It says, I'm quite happy to write an account up. What will it write? Ooh, do we know? Is this exciting? Yes, of course it is. Run the program. Take a look. What did it write? It wrote etiquette.account. Oh, that's useful. So it said, you're in the etiquette namespace. Yep, you are. There you are. And you're called the account class. And so it's basically not told me anything useful, which is kind of sad. Okay, but it did compile, which is kind of happy. So on average, we're kind of about where we want to be. So if I do that, it just prints out the name of the class. It doesn't print out anything in there, which is annoying. Because what I'd like it to do is print out account name, Rob, number, blah, balance, blah on the screen. That'd be nice. Okay? We can make our own toString. We can make that toString behave in a manner that suits the class that we're creating. This is a nice piece of etiquette, because people that use our object may well want to print it out or view it somewhere in text form. And so providing a toString behavior is a very nice thing to do. This is a word you're going to see a lot of in the next few lectures, and that's the word override. If I could make the mouse move, I could find it. There you go. Override. We're going to override the methods in our parent class. That's probably kind of important, and don't worry too much about this if it doesn't go in first time, because it took me 2 or 3 goes as well. We are talking about class hierarchies here for the first time, and we start to understand exactly how it is that C# manages things in the program. At the very tippy top, in my wonderfully realized art, is a class called object. Object exists in a C# program to act as the parent of every other class in the universe and space. So every class in C#, every type in C# is descended from object. Object is the parent, it's the daddy of them all. It's the parent of everything. Everything is descended from this particular class. And that means that account is automatically a child of object. I can kind of, well, let's keep on going and see where we end up with this. The idea is that if I'm a child of a parent class, I pick up all the behaviors that the parent has got for free. Okay? The object has, well, have we made objects? No, we haven't. Let's make an object. This is going to be so interesting. Watch this. Object. Object. O equals new object. So I've made one of the original building blocks of C# programming life. I can then write him out. console.writeLine, oh, and it will say that's fine. If I run the program, let's see what it prints. It prints etiquette.account, fine, system.object. So it looks like the toString method for the object class simply prints out the name of the object, correct? So we know the object class lives in the system namespace, and it provides a few simple behaviors. If you still don't believe me, if I right click on this guy and go to definition, there he is, public class object. He has a constructor, he has an equals method, he has a reference equals method, he has a get type, oh, and he has a toString. Look at that. And that's the method that's being called when we make our string output from the class at the moment. So we've got a toString which we've inherited from our parent, but it's the wrong one. We don't want that one, we want a new one. And that's the basis of overriding. I pick up all the behaviors from my parent, and I then modify the ones that make more sense. This is the basis of inheritance. So there's my object. It's part of C#. You can make them. You can actually, occasionally, I do actually use the object type for this and that, but most of the time I make things which are descended from object, like int, float, double, decimal, account, blah, blah, blah. And we'll discuss how you extend things a little bit later in the course, in a week or so's time. But for now, that is an object. Turns out, if I want to produce an object toString behavior from my account, then I can add a toString method which overrides the one in the parent. And the key here is this word. Oops, well, override. It means don't use the one in the parent, use me. So if I ever call toString on an account, it will call the toString in the account class, not the one in the object class. We've talked about overloading, which is when you have lots of copies of a method, all with different parameters. This is overriding, where I replace the behavior in a parent class with one that better suits what I want to do. If you're not sure what that means, I'll show you in the code. So I go back into my account, and this is where Visual Studio starts to shine again. I go public, override, and it goes, okay, Rob, what are you overriding? I'm going to override toString. Bang. And by default, it says, okay, just call the base one and use that. I don't want that. What I want is I want to go return name plus name, and then plus a space, and then plus space, oh no, so it's balance, and then, oh, not going too well today, balance. So now when I ask the account to print itself, we won't use the object toString anymore, we'll use this one. So the override keyword means replace the behavior in my parent with one more suited to me. So run this, bang, take a look at what's come out. So name Rob, balance naught, and then out comes the system.object, the default toString behavior. So I've not changed the write line at all. All that happens now is when it has to convert this guy into a string, it goes, oh, I must find your toString behavior. I wonder where that is. And it rattles off and gets this one. So that's kind of cute. It means we can create our own types and then provide behaviors for them which link into the system. So now every time we want to get a string that describes our account, we just print it. And bang, out it comes. It's called toString, and it just works. Does that kind of make sense? The idea is that your base type is kind of abstract and has a whole bunch of abstract behaviours, and then we drop down to the children, and the children have specific behaviours which suit the context in which they're being used. So the account will print the account name and the account balance, whereas the integer prints out the integer value, and the character prints out a single char, and decimal prints out a decimal number, and blah blah blah. So we have this ability now to modify the behaviour of objects to make them even more specific, even specificer, if that makes sense. Can you see where I'm going with this? Now, it's good etiquette to do this, because it means that somebody can actually now get the string out of my account class and display it. And since I'm kind of keen on testing, and since I'm kind of keen to be able to see what's inside my objects, I tend to use things like toString to make that really easy. I could write a thing that grabs the account, pulls out the name, pulls out the balance, and then writes it into a string. That's a bit tedious. It's best if the account does that for me. So what I can do here is I can actually get that behaviour simply by doing this overriding trick. Okay, that's as good a time as any to stop, I think, and we'll carry on with this in a couple of hours.